Okay, here we are. We're going to finish up a rational exponent lesson. We've got x squared plus 1 raised to the 1/5 power times x squared plus 1 raised to the 4/5 power. Again, we have the same base, and our rule is keep the base. Because we're multiplying, we're going to add the exponents. So we'll have x squared plus 1 as our base, and then we're going to have 1/5 plus 4/5. 1/5 plus 4/5 is 5/5, and 5/5 is 1. So our answer here is x squared plus 1. So using the same rules, but this time we have fractional exponents. Here we have 32 raised to the negative 2/5 power. First thing I'm going to do is I'm going to make that negative exponent positive by putting this 1 over 32 to the 2/5 power. Now I'm going to practice by taking the 5th root of 32. The 5th root of 32 is 2. And then we've got that squared. So I've got 1 over 2 squared, which is 1 over 4. Now that's where I'd love for you to be at right now, is to be able to go from 32 to the negative 2/5 to 1 over 32 to the 2/5, and then 32 to the 2/5, 2 squared in the denominator. But if you need to use our rules, we've got 1 over the 5th root of 32, and then take that answer and square it. See, so that numerator is going to become the square on the outside. You're still going to get 1 over the 5th root of 32 here is 2. 2 squared is 4. Let's try it here. Negative 8 raised to the 4/3 power. This denominator of 3 means the cubed root. So this is the cubed root. What's the cubed root of negative 8? The cubed root of negative 8 is negative 2. So the cubed root of negative 8 is negative 2. And then we're going to raise that to the 4th power. So we're going to have negative 2 raised to the 4th power, which is a positive 16. So negative 8 raised to the 4/3 power is positive 16. And some people will get better at this, some pretty quickly. Some people will get better at this with a little bit more practice. But all of us can get better at this just by thinking about what we're doing, persevering, and not giving up. The cubed root of negative 8, and then raise that to the 4th power. You too may be able to do this without showing a lot of work. Now, you need to be honest with yourself, though. You need to make sure that you're not just copying or doing something like what they call photo math and just getting an answer when you're doing your homework, because that's not going to help you in the long run when it comes to being able to do this math on your own. You need to be able to just put in a little extra time, and you'll get it down. Okay, here's 2 more problems that we have for you. And in one of these problems, I'm going to explain something really important, so hopefully you'll be listening. We're going to combine these radicals. We've got the square root that we want to combine with a cubed root. A square root with a cubed root. First step is to rewrite as rational exponents. So rewrite in exponential form. Okay, so we've got x to the 1/2. How did we get that? That's raised to the 1st power, and the 2 is there in the index, so that's x to the 1/2. Remember, 1/2 power is your square root, times y raised to the 2/3 power. Now, in order to write this under the same radical, to combine those radicals, we need to get the same denominator. So we want a common denominator. Well, we all know the common denominator between 2 and 3 is 6. So x to the 3/6, y to the 4/6. So 1/2 equals 3/6. 2/3 equals 4/6. And now we can use that 6 as the common index, right? And then we have x cubed y to the 4th. So our last step is to rewrite as one radical. We were able to combine those radicals. Now you can try this next one, but it is a humdinger. There's a lot there. There's a lot going on there. So we've got the square root of the cubed root of x, the 4th root of y cubed, and the 5th root of z to the 4th. So let's see what our first step was. Rewrite in exponential form. So this might take some baby steps. I'm going to start on the inside. We've got x to the 1/3, y to the 3/4, z to the 4/5. Okay, so x to the 1/3, y to the 3/4 over z to the 4/5. And that's all raised to the 1/2 power. So that square root is the 1/2 power. So I can try and find the common denominator of 3, 4, and 5, which is 60. And then slowly work up to that common denominator with that 1/2 power. But I want to show you something else. 1/3 times 1/2 is 1/6. So this is a little bit more intense, but there's a reason why I'm going to show you this. This is not the fastest way to do this problem, but it is going to allow me to show you how to get a common denominator like they should have shown you when you were in elementary school. So I just reduced that 4/10 to a 2/5. So I have 6, 8, and 5 that I want to get a common denominator of. 6 is 2 times 3. 8 prime factored is 2 times 2 times 2, and 5 is just 5. Here these two values share 2. So I'm going to take one of these 2's times all the factors that are left over. So 5 times 4 is 20. 20 times 3 is 60. And 60 times 2 times 3 times 2 times 2 times 5. That's going to equal 120. So my common denominator is 120. So 5 goes into 120. Let's see, that would be 24 times. So 2 times 24 is 48. So z to the 48 over 120. And then 6 goes into 120. We're looking at the x to the 1/6. 6 goes into 120 20 times. So that would be 20 over 120. And that reduces to 1/6. And then 8 goes into 120. That would be once 15 times. And then 3 times 15 is 45. So 45 over 120. And now we can rewrite this as the 1/20th power, or 1/20th root of x to the 20th, y to the 45th, over z to the 48th. Now, I really just wanted to show you this part right here. I really wanted to show you how to find the least common multiple, lowest common denominator using this, because many times people will just say 5 times 8 times 6, and then you're going to end up with a 240. 240 is not the lowest common denominator. 120 is. But I could have also done this. 3 times 4 times 5. 3, 4, and 5. We wouldn't have any 3, 4, 5. You'd have a 3, you'd have a 2 and a 2, and you'd have a 5. I wouldn't be able to circle anything here. So 3 times 4 times 5, well, that would be 60. And then I could slowly say, well, if I make this a 60th, that would be 20 over 60. And if I make this a 60, 4 goes in that 60 15 times, so 15 times 3 is 45. And then if I made this a 60, 5 times 12, so 4 times 12 is 48. And that would be to the 1/2 power. And then I could take 20 over 160, 20 over 60 to the 1/2. You'd power to a power, you'd multiply, and you'd get 20 over 120. And then power to a power, you'd multiply, and you get 45 over 120. And then power to a power, you'd multiply, and you get 48 over 120. So that would be a little bit faster of a way of getting to that 120, but it wouldn't allow me to do what I did here in purple. And that's our final answer, the 1/20th root of x to the 20th, y to the 45th over z to the 48th. That's how we rewrite it. That's how we rewrite it and combine the radicals. And this is just a whole bunch of good fractions and common denominators and arithmetic.